and welcome to this NLJUG University session. We are here gathered tonight to see one of the great minds from the Java landscape speak and share his experiences. Before we start, I'd like to express a word of thanks to our partners, Craftsmen and Blue Variety, who arranged the location and the food and all the practical stuff. So a round of applause for Blue Variety, Craftsmen, please. So I think it's time for me to clear the stage for the person you've all been waiting for. It's a guy who has been booked more than most of the other speakers in the Java landscape. He just told me this morning that he was booked until October 2018. So if you want to book me, you need to be quick. But we have him here. A round of applause, please, and a warm welcome for the amazing Dr. Venkat Subramaniam.
Thank you very much. I really appreciate it. Thanks for the opportunity to be here. I want to talk about something that we all care about a lot, which is to deal with code quality. How do we really get better at what we do? And that's what I'm going to focus on today. We're going to go for about 45 minutes, and then we'll take a break, and then we'll go for another 45 minutes after that. So let's get started. So I want to talk about 12 ways to make code smell less. And why 12 ways? So I kind of picked a number and said I'm going to think about 12 different ways, and things did fall in place. But I'm going to start with a question first of all. So there are maybe 4 kinds of people out there. There are the how kind of people. They want to know how do you do this, how do you do this? And then there's this what kind of people. They want to know what are you doing, and then there are these when are you going to get this done? And then there are these why kind of people. Why are we doing it? I'm mostly a why kind of person. I want to know why we are doing, because if I know why we are doing something, then maybe we will be a lot more motivated to do it. So I want to start with the question, why should we care about code quality? And I'm going to say the number one reason I want to really focus on code quality is we cannot be agile if the code we are writing is of very poor quality. It's really hard to do it. We live in a world of where everybody wants to be agile. But what is really agile development? Well, agile development says that using feedback will evolve systems, and it's perfectly okay to change things even late in the game. But you're sitting in this meeting, and you're listening to what they're suggesting that we should change. And then you realize to make this particular change, you have to touch that XYZ module. And then you realize that the last time you touched the XYZ module, you could not go home for the weekend. You're going to convince people, maybe we shouldn't do this. So you cannot sustain development if the quality of code is really poor. So that's one of the reasons. But I then realized there is yet another reason we should really care about code quality. And that is, the code is how you tell your colleagues how you feel about them. Do you love them, or do you hate them all? How many times you sit with the code and you realize, why did the person write this code? What was he thinking, or what was she thinking? And it becomes really hard. So if we really love the people that we work with, we want to write the code in a way that can actually maintain it. That becomes another important reason to do it. Well, it turns out lowering quality of code lengthens the development time. So if you want to really go slow in what we do, maybe we should really create poor quality. But if we want to go faster and gain speed, the quality can help us to get there. But the question really is, how do we define quality of code? How do we say this code is of good quality? There are several definitions for it. Well, once I came across a guy who had a really interesting way to define code quality. He said, this code is really good because I wrote it, he said. No, we have to have a better way to define it. Well, so here's my definition of code quality. I'm going to say that the quality of code is inversely proportional to the effort it takes to understand it. If you take more time and effort to understand the code, that's poor quality. If you take less time to understand a piece of code, that's better quality. I do a lot of code reviews, and one of the things I tell my developers is, if I spend more time on your code, that's not a good thing. You want me to come in, understand it, move on. So you want to really be able to come in and understand the code very quickly. Those are some of the reasons to really consider code quality. So we're going to talk about 12 ways that can help. I'm going to count down these 12 ways. Let's start with first one thing that's really not even that technical actually. I'm going to say the first and foremost what I would recommend is to schedule time to lower technical debt. Now, when we deal with software projects, we all understand and agree that we have technical debt. And when I go to companies, if I ask them, do you have technical debt? Almost everyone will say, yes, of course we have technical debt. But one of the very first things I ask people is, show me your list of technical debt. So in other words, I want people to list their technical debt. In the work area, on the wall, I want to see a list of technical debts written down. I want them to be written down in the order of the most annoying technical debts to the one that's the least bothersome. And when you prioritize these, and when you have it on the wall in the work area, what's in front of you becomes visible every single day. And then we can easily act on it. But a lot of times, a lot of teams will have technical debt, but they never write it down. And when you don't write it down, it kind of becomes a little hidden as time goes on. Well, the term technical debt, this was coined by Ward Cunningham. And he coined this when he worked in the financial industry. And he noticed that the financial world accrues debt. For example, home mortgage may be a healthy debt. Credit card debts is unhealthy debt. So there are debts that you willfully get, and there are debts you shouldn't be getting really. And just like in the financial industry, what happens if you don't pay your debt on time? That's exactly what happens to projects when they don't take care of the technical debt. They lead to bankruptcy, financial bankruptcy on one side and technical bankruptcy on the other. So we want to really be able to take care of these debt along the way. But paying this debt is not easy, but we have to put a very active effort into it. So let's say I go get a credit card and I start charging onto the credit card. And at the end of the month, I realize, what a novel idea. I don't have to pay all the money that I've charged on it. I can only send a minimum amount that's due. If I do this, what happens? The next month, I go on charge more. I got a little bit more I owe, but I can still send the minimum balance. And if this continues for a while, suddenly I realize I've exceeded my credit limit. What happens when I exceed my credit limit? Well, the bank sends me a letter saying, hey, dear customer, you have exceeded your credit limit. But they don't stop right there. Then they go on to say, but you are a valued customer, so we increase your credit limit. Because the bank never wants me to get into trouble. They want me to get into real trouble. So now what happens? I start charging more because this is so much fun, I can keep charging. At one point I realized the money that I owe on the account, on the credit card, is larger than my yearly salary. At this point, the only options I have is to grow a beard, change my name, and move to another state. Just for the sake of record, that's not the reason I left the state of Texas. But the point really is, you don't want to be accruing debts like this, you want to start paying. So for this, you want to really start scheduling time. But one of the really troublesome parts of technical debt is, a lot of times you don't even have to do anything to start accruing technical debt. So you have installed this application you have in production, but it's using version 4.7.6 of this particular framework. 6 months went by, and the framework has moved on 7 versions already. And now you're like, wait, we're versions behind, we have not upgraded it, and then you realize the upgrade path is really hard, and that's a technical debt you have accrued already. Oh, that schema we've been developing for a few years has gone out of bin because we've been kind of updating it along the way as the requirements started changing, but we really need to revisit the schema, but you haven't had the time to do it. Well, but writing poor quality code is not technical debt, that's a technical sabotage. So we really have to know what these terms are because it's easy to misuse the term and feel comfortable about it. But it doesn't have to be all or nothing proposition. So one of the things I would recommend is to schedule time to start paying technical debt. In projects, we often allocate time for development. We also schedule time for planning, for meetings, and we also have time for vacations and sickness and stuff like that. But we also have to schedule time for paying technical debt. So we could start a sprint and say, well, in the list of all the technical debts we have identified, here's the very top one, and we're going to have him work on this technical debt for maybe 15% of his time. We're going to have her work on this part, maybe 10% of her time on the second item. So we will take the topmost technical debt and have developers spend certain percent of their time working on this technical debt, and then we can start minimizing it as time goes on. Going on this topic about scheduling, I want to also touch upon one more thing that I think is important for us as developers to consider. And I learned about this from this wonderful lady called Linda Rising, and she said something that really made me think much more deeper about what I do personally. She used a metaphor which really stuck with me. The metaphor she used was, she said that a freeway filled with cars is a parking lot. And what she means by that is, if you take your schedule and you fill up every hour of your schedule with the work you want to do, you will never be able to complete on time. We always take on things that take a little more time than we expected. And if you fill your schedule so tightly, you have no way to really recoup from the things that don't get completed on time, and we have already set up ourselves as failure. So there's got to be a wiggle room in our schedules. But she goes on to say, and she said one other thing that really shook me, and she said, if you never have slack time on your schedule, and you as an individual, as a team, as a company, as an organization, if you never have slack time on your schedule, you will never be able to innovate. And when I heard her say this, it really shook me, because I'm a consultant. If I'm not at a client side doing work for them, I don't get to invoice. So it's in my interest financially to schedule all my time for my clients. And when I heard her say this, it really made me think, and I started changing some of the things I do. What if I take 2 weeks in a year and I don't schedule anything for my client work? That 2 weeks I have nothing to do on my schedule, and the day arrives, when you start the day when you have nothing to do, this is wonderful. Because you think of all the things you always wanted to do, but you never had an opportunity to do it. And one of the things I saw on Twitter, somebody tweeted this, I thought this was a brilliant tweet. And this person said, what do you mean we have to fix our fence? We are busy chasing the cattle. That's a really beautiful metaphor. We don't have time to fix our fence because we are so busy chasing the cattle around. This can be applied to a lot of things we do. What do you mean we have to write automated tests? We are so busy fixing bugs. What do you mean we have to improve the quality of code? We are so busy dealing with all the problems we already have on our hands. And this happens a lot. But when you schedule some slack time, it gives you time to go learn things you probably never had time to learn. It gives you opportunity to try out ideas we probably never had time to do. And so how do we do this? Well, you could provide maybe a few weeks in a year. But that's more of a waterfallish approach. What if we provide maybe half a day every week? What if we provide 15 minutes every day where you can do whatever you want to do and you don't have to work on your project? So what I tend to do these days is I would take on stuff that has absolutely no relevance to what I do. I take on things that has absolutely no relevance to what my clients do. And I would just start poking around things that seem intriguing, and I would give myself that 15 minutes a day, or maybe if there's enough interest in it, maybe half a day on a week. And consistently, the next project that I work on, or the next client I take on, often comes from that area. Because you are able to really innovate and find resources in areas you never thought about, and you're gaining strength in the area, and that opens up market and opens up opportunity. So the slack time is extremely important for us to have. This is emphasized by this wonderful book on Guns, Germ, and Steel. And in this book, he talks about how humans were pretty much hunter-gatherers once upon a time. If they don't go out to hunt, they're not going to have food. But then humans started doing agriculture. They started producing grains, and they started storing it. They also found out that they could actually start domesticating animals. And for once, in the beginning, the humans didn't have to go hunting. You could wake up in the morning and you could just sit there and relax. You didn't have to go out. You could take the grains from the store and you could use it. You could play with this lamb all day, and when you're hungry, you could just kill it and eat it. I mean, this is amazing that you don't have to go hunting. Well, gosh, what are you going to do when you don't have to go hunting? Well, I could put my effort into creating art, maybe. I could create music. I could create various other things. Well, the human civilization started growing when humans didn't have to really start constantly looking for food. This is so true for a lot of things we do. What if I don't have to go to work this morning to work on this particular code? I can start innovating and become more productive over time as well, so that becomes really, really important for us to do. The next thing I want to talk about is to favor high cohesion. Well, what is cohesion? Cohesion is where A piece of code does one thing and it focuses on doing that one thing really well. But again, the question why? Why should I really make the code cohesive? Well, it's really about cost and frequency of change. As time goes on, a software has to change. If somebody tells you that I created a piece of software, but I never had to change it after that, what they're telling you is the project got canceled. Any software that's relevant has to change over time. But in order to change a piece of software, you don't want to change everything in it. You want to be able to change minimally to get the change of the software, so that frequency of changes to be something we need to really consider. So the change has to be really narrow focused, and the code has to be narrow focused for that. And the frequency and cost of change really matters. But one way to really look at it is to look at the cohesion, is to look for the cyclomatic complexity. A code with high cohesion often has low cyclomatic complexity, and a code with low cohesion, which is not a good thing, usually has high cyclomatic complexity. So you really want to be able to create a code where the cohesion is really high. But when we write code, the problem really is not that we don't really know this. The problem is the reality kicks in. And when we start writing code, the code tends to rot over time. I came across a client who once said, let me show you something, come over here, and he took me to his machine to show this. These guys have been developing this software for a good 30 years, which is a little overwhelming for me, because when I'm in this company, there are people who wrote the first line of code still working on that project. And he said, let me show you this, and he puts this cursor on the timeline, and he shows me this piece of code, a function 15 years ago. And you can see this function, the day it was born, beautiful, just red around its ears, little fingers, just absolutely cute looking little function. And you look at this, nice name for the function, just 1 or 2 parameters, so small you can actually see the whole function in front of you. And he points me to the cyclomatic complexity of this code, a value of 5. And I was still admiring this. Oh, such a beautiful, beautiful function. And then he said, yeah, don't get too excited. And he moves the cursor to the timeline. And as he does it, you can see this code change and become a monster in front of you. The only thing left as a remembrance was the function name. Everything else was different. Huge number of parameters, very long function. And then you're looking at this monster, and he says, look at the cyclomatic complexity, and a value of 864. Where a value of 10 is considered to be complex. And I'm like, wow. He says, that's what we do to code in this company. And it's scary, right? And as time goes on, the code becomes complex, and everybody dreads working on the code. You find this programmer and say, I got a news for you, you're going to work on this. And he says, why am I the victim? I don't want to work on this code, right? People dread these kinds of code to work with. So cohesion is extremely important. Well, so what is cohesion? Where a code is narrow focused and does one thing and one thing really well. Well, my parents really tried hard to teach cohesion for me. When I was a kid, they said, Venkat, you have to really keep things, like things together, unlike things apart. But it never made sense to me, because it was a lot more faster to come home from school and throw things into a drawer and run away. It was fun playing on the streets and never fun being inside the house. So as a kid, you realize you want to minimize the time in-house and maximize time outside on the street. So I would come in and throw things and run away to play. And when I did this, if you ever open the drawer, I cannot guarantee what you will see in it. There were books, there were toys, there were clothes, there were used clothes among them too. And who knows, there could be snakes in there as well. And if you ever pulled a red sock, the next sock would not be red in color. Nobody knows what the next random color would be. It was optimized for throwing things in, never optimized to find things out of it. And that's the way I kept it, and they kept telling me, that's not the way you live, that's not the way you keep things. And it never ever made sense. I know what you're thinking, gosh, this guy sounds really terrible. How did he turn out to be the way he is today? I got married, and that fixed me everything. And the whole point is now in my house, what a concept. My kitchen has utensils, not my books. My bookshelf doesn't have knives and fork, which used to be there before. And there's things kept in the right place, and everything is quite orderly. And that's the whole idea of cohesion. Yes, it takes a little bit more effort to put things away in the right place, but it's really optimized for taking things out. That's exactly about code as well. It takes a little bit more time and effort to write this code, but it becomes a lot more easy to read it, a lot more easier to maintain it as well, so we want to make it cohesive. We also want to focus on coupling. Well, of course, we always hear people tell us, favor loose coupling, but I don't agree with that. I have a little bit of a bigger ambition than that. Well, of course, tight coupling is really bad. The keyword that's a really ugly keyword in Java is the keyword called new. Well, what does new do to us? New leads to tight coupling. The minute you say new x, you are dealing with the value, the class x, you're tightly coupling to it. The entire slew of abstract factories were created just for us to decouple. So an entire pattern resides because the poor new is not polymorphic. And so we want to really favor loose coupling and not tight coupling. Tight coupling leads to code that's really hard to extend, but tight coupling also makes code really hard to test as well. So we really want to make the code extensible and easier to test. So for that we say go towards loose coupling. Well, what is the difference between tight and loose coupling? Tight coupling is when you depend on a class. Loose coupling is when you depend on an interface. Well, that's a really good idea. I really don't want to keep thinking about it that way. Because the reason why I'm not a big fan of that is, as programmers, we deal with what I would like to call as incidental coupling. And incidental coupling really, really hurts us. And to give an example of this, I was in a conference where it was not a conference where people talk about stuff as somebody presents and somebody listens. It was an open space conference. One of the topics for the conference was, we all love automated testing and unit testing, but our mock objects and test doubles really make it hard for us to maintain our test. This was a very intriguing topic, one that I'm really passionate about. So I gravitated towards the room and I stood by the door and I started listening to about 30 people in the room, and they were talking about how they all very actively do unit testing, but their test doubles, mocks, and stubs make it really hard to maintain the test over time. After listening for a few minutes, I interrupted and blurted out saying, hey folks, I just want to have maybe a question or a comment. I'm just wondering, maybe you're having all this trouble with your automated test and unit tests, just maybe because your design sucks. And by saying it, I offended everyone in the room. They were like angry. Hey, who are you? Why would you come and tell us that we don't know how to do design? I said, I write design that always is very poor. I thought you guys are like me. And then they said, one of the guys said, well, let me give you a problem I'm dealing with right now, and you tell me how you would do this. So he puts up on the wall a little diagram and shows how the dependencies exist in the system. And at this point I noticed, well, true, you have a dependency because the problem statement says there's a dependency, but that doesn't mean there's actually a dependency. For example, if I were to tell you to go get me water to fill up this glass, well, I could be having a glass like this. I could have a glass with different shapes on it. It could have curvatures on it. And now you're going to ask me, what kind of glass is that? Well, are you trying to fill up to the brim? Are you filling a little less? Or if you have curves on it, are you going to consider that too? And notice now, you're leaving me thirsty while you're arguing about what to fill. But instead, if you tell me, I don't care about your glass, just tell me how many ounces of water you want. Or tell me how many milliliters of water you want. Oh, get me about 12 ounces of water, please. And then you don't care about this particular glass. The dependency on the glass goes away. Your focus is kept on the water that you want to bring in. So the whole point about this is, I'm feeling that there's a lot of times we're dealing with dependency, and these are incidental or perceived dependencies, and that really makes it hard for us to design. Here's an example. If you notice, this class on the left depends on the class in the middle, and the one in the middle depends on the class on the right. Let's say the class on the right, the red one, is very non-deterministic and maybe a little slow and unpredictable. I am interested in writing tests for the one in the middle. If I'm going to write 20 tests on the code in the middle, every single of those 20 tests is going to be brittle and complex because I have to use a test double for the code in the right side. That I have increased complexity quite a bit writing these test cases. But instead I realize that in this case, I am sending this data to this particular function, this particular code in the middle, and it goes out and gets another piece of information from this one. What I could do is say, I'm not going to send you one piece of data anymore. I'm going to send you two pieces of data. The one that you originally received, but the one you went on and obtained from the other class. all of a sudden this code doesn't really need any test doubles anymore. Of course, the dependency was not removed, but the dependency was moved in this case. As a result, you can see that this dependency is here, but it can get the data and send to us. Good news, we minimize the effort to automate and test this. The design became a little easier to work with. But wait a minute, by moving this, didn't we not just shift the problem from one place to another? And the answer is actually we didn't. And the reason is, when you have all these tests here, this interaction is very fine-grained. It takes a lot more effort. However, this interaction is a lot more coarse-grained, so you don't need as many test doubles as you once did, and you can minimize the effort. And I'm beginning to notice this quite a bit in applications I work with, by either removing, or if not, by moving dependencies, I can actually make the design a lot easier, but also make automated testing much more affordable as well, manageable as well. So we talked about scheduling time. We talked about favoring high cohesion. We talked about lowering coupling, but also to eliminate coupling in a lot of places. But the next thing I want to talk about is to program with intention. Now, this happens quite a bit. We get a little frustrated, we get confused, we get carried away, and we begin to program accidentally rather than programming with intention. I had such a wonderful time with my client 2 weeks ago. I was writing a piece of code, re-implementing something they had in place. So I made a function call, and within that I accessed an array with an index, and it did not work. I turned to my colleague who was next to me and said, hey, it doesn't work. He said, do index plus 1. I did index plus 1 and the code failed. And I quietly turned to him and said, it doesn't work. He said, try index minus 1. I looked at him and said, are you serious now? And he said, okay, let's understand what this code is doing rather than trying all this. And sometimes we do this. That's not called programming. That's called working in desperation. And we do this sometimes, right? I want this damn code to work. I don't know why it's not. Try this, try this. Okay, it's working. What did you do? I don't know. But it's working, right? Well, we do this program with intention sometimes. I think this particular thing summarizes our feeling quite a bit. I saw this and I thought, this sums it up really well. It says, when I wrote this code, only God and I understood what I was doing. Now God only knows. I'm sure we have all come across code like this before, right? You look at this code, you are denying you ever wrote this code until you find your name in the version control as the person who checked in this code, and you're like, really? And you've forgotten all this memory of writing that code. And this happens quite a bit. So what do we do about it? I'm a huge fan of this rule by Ken Beck. And the rule of simple design says, the first rule of simple design is the code passes all the tests. There is an implicit assumption in there. We actually have tests that would pass. And the second thing is it reveals intention. There are no duplications in code, and it's got fewest elements. The last one is my favorite. It is about minimalism or parsimony. The people that I work with will know and get annoyed. I'm always like, do I need this? Do I need this? Do I need this? I'm of the opinion that minimalistic design is better. I'm of the opinion that the code you did not write has the fewest bugs in it. So anything we can do to avoid writing code is a lot better, and minimizing the amount to be put into it. Ken Beck talks about this in an order of priority or decreasing priority. He says passing the test is more important than revealing intention, which in turn is more important than no duplication. If you have two opportunities, one is to duplicate, but the other is to reveal the intention. He says in that context, prioritize revealing intention more than removing duplication. Well, following these rules can help us quite a bit. This is one of the reasons why I also like to write automated tests, because before I write the code, I write the test. It makes me think about what my code is supposed to do to help me to reveal the intentions quite easily. So we want to really focus on the real purpose of the code and work with it. We also get into this one problem of primitive obsession. And I've noticed this quite a bit among developers, me included, that is. We tend to really take ownership of this and write the code. But I'm beginning to ask one question. When you sit down to write a piece of code, just pause for a minute and ask this very important question. Am I the chosen one? Are you the chosen one to write this code on planet Earth? if this code is so domain specific, so specific to your project, I've got a great news for you. You are the chosen one. But if this is a general purpose code, very likely somebody wrote it already. And very likely they did a better job writing it. Because you are trying to write it among the other million things you have to do, but those were the chosen one for that. And they probably wrote it better. And if they have written it already better and you writing it again is an act of duplication because somebody else has written it already. But a case in point, this happened a few months ago. We had really good automated tests, so to the credit. But I was looking at a function. And in that function, we had 30 lines of code. And I'm looking at this 30 lines of code, and something tells me, why did this developer have to write it? Because I don't feel this developer was the chosen one. It's a common problem. Other humans would have seen it already. Why does this developer have to take the time to write it? And from that hunch, I started searching a little bit. And to my surprise, I found that function readily available right there in the JDK. And now I'm like, gosh, this is already in the JDK. You don't even have to install a third-party library. And all I did was I commented out that 30 lines of code, just made one call to the JDK, saved the file, made sure the test is passing, and I quietly checked in the file, didn't say a word. About an hour went by, and I saw the version control, the file change in the version control, and I was like curious. I just did a pull, and I looked at it. Well, the developer who had written this code noticed that I had modified the file. Obviously, good developer was curious, looked at it, and realized that I had commented out all the code he had written and replaced it with one call to JDK. And very smart guy. He quietly took the commented part and deleted it and checked in the code very quietly, didn't say a word. But I'm sure some learning happened right there. The point really is we don't have to be writing all that code. But at the same time though, I'm going to say imperative style is packed with accidental complexity. Imagine if I tell you to take 2 5 pounds weight or 5 kilos weight, depending on what you want to say, and I'm going to ask you to wrap it around your wrist. And then I tell you to start typing. How would you feel about it? That's kind of what imperative style of programming is. We have been programming in imperative style for a few decades now. I do have to tell you, I spent my youth and childhood programming in imperative style. That tells you I had a terrible youth. And all those misguided years when I wrote more complex code than I should really write. Well, let's take a look at an example to understand what this really means. So here is a little isPrime function. And the isPrime function tells me whether a number is prime or not. Don't care how it's doing it. That's what it tells us. Then you see this method called main. It's got an n and k. It calls compute. Let's focus on compute. What does compute want to do? The compute says, find the total of the square root of the first k prime numbers starting with n. Okay, so I want the total of the square root, but of prime numbers that start with n, but only k of them. The problem is not a complex problem. The problem is a fairly simple problem. I never want the solution to be more complex than the problem that's given to me. And if the solution is more complex, then we are dealing with problems created by the solution, not the problems created by the problem itself. But let's do this in the imperative style that we all are very familiar with. So what am I going to do? Double result is equal to 0. I want to return the result out of this. Well, that's a good start. Then I'm going to say int over here, index is equal to n, int count is equal to 0. So what did I do so far? Absolutely nothing useful. All I did was I defined a few variables. These variables are called garbage variables. These are garbage variables because they're not needed by the problem, they are needed by the solution. I bet you we normally don't give names like this to them. You probably call this as temp. You probably call this as something like C or whatever it is. This is how we show our discontent and say you don't deserve to live, but I have to define you because I'm required to, right? And we kind of express our feelings about code quite a bit in doing this. Well, then what do? Then I say while count is less than k, and you come to a screeching halt at this point and ask this wonderful question. Is it less than or equal to? Do you ever ask this question? Every single time. There is only one purpose of that code, to make us feel stupid. Because every time you write it, you stop and say, let me think about this. And you are never sure about it. You are squinting your eyes, you're thinking about this. Boundary is here, it's less than. No, it's less than equal to. You want to really go to the restroom. Your body moves, your mind is there. You're still thinking. You're walking in the corridor, somebody says hello, there's a delay in your response. Oh, yeah, hello. You are having dinner at home, very painful. Your family says, are you okay? Yeah, I'm fine. Are you okay? I am fine. Are you really okay? I'm saying I'm fine. Well, you look a little pensive. No, I'm fine. Just not sure if it's less than or equal to. And this nags us all the time. So what do? Then we say, in this case, if is prime index. Well, if it's a prime number, what am I going to do? Hey, good news. Result plus equal to math.square root of index. And there you go. That's the code. Is it correct? No, I see a few people shaking their head. No, it's not right. What am I missing? Increment the index. Let's increment the index. Index plus plus. Are we done? What am I missing? Increment the count. Count plus plus. Am I done? Still wrong. What's wrong? It's got to be outside, you said. Okay, I move it outside. Is it correct now? You're saying, no. This has to be inside. How rude. You're looking at this. Is it correct now? Did you notice just what happened? You went from saying it's not correct to, I'm thinking still. I tell you, programmers are the smartest people on earth. Because when you show them code and say, is this correct? They will tell you, it looks good. Because they know never to say it is correct. It looks good. Because 3 weeks from now, when you find this bug, they will say, it only looked good. I didn't say it is right. So, okay, we got some code running. Let's run it. And what does it do? It gave a result. Is it correct? It looks good. But if you look at this code has packed accidental complexity into it. You stare at this. You think about it. You walk through it up and down. You're trying to see these, and you are nervous. And you're like, I don't know. So I have this theory. It is code like this that prematurely turns programmers into managers. They said, I am done. I will leave these for you guys to deal with. The people, the programmers in this room, you are the survivors. Because you said, I'm going to wipe all those tears, I'm going to wipe all those sweat, and I'm going to come back the next morning and do it again. That's the courage you have, right, to do it again. But that's a lot of work. Maybe we can do this a lot better than this. Let's give it a try. Let's go back to this code and say, I will comment out all of these for now. Let's see if we can do this a little differently. And I'm going to say return stream.iterate. And in this case, start with n, given an element, element plus 1. So this says I'm going to start by iterating from the n, but then I'm going to do a filter, and I'm going to simply say sample right here of is prime. And then I will say dot map, math of course, and square root, and I'll map this to double. And finally at this point, I'll go ahead and say dot limit k, not less than k, not less than or equal to k, just k. And then you say dot sum and ask it to perform the operation on it to get the result. But if you look at this code, notice that you can go through this in one pass. Given all the numbers starting with n, give me all the prime numbers starting with n, give me the square root of all the prime numbers starting with n. Oh, but only give me k of them and total it. If you look at the code in the top, you are staring at this code. You're trying to figure out what this code is doing. And that's when your business analyst comes to you and says, hey, what are you doing? And you tell the business analyst, I am trying to find out what this code is doing. You shut up now. And that's how you feel frustrated. Whereas if the business analyst comes to you, you can say, let's have a conversation. And you're able to walk through the code because the code begins to read like the problem statement. So when you look at code, I have a philosophy about good code. A good code should read like a story, not like a puzzle. The code in the top is like a puzzle. You put it out there, and people have to figure out what the code is doing. They got to kind of somehow extract the details from it. And when you put puzzles, what happens? Developers sometimes take hours, sometimes days, sometimes weeks to find what's happening. You're sitting and working one day, and you hear the scream in the next room. And you pause for a minute and say, they got it. And eventually they found out how the code is working, right? And I remember this. This was a very, very difficult experience for me personally. I once worked in a company. This is really heartbreaking. I worked in a company. They had a piece of code. No one understood how this code worked. It was a very complex math, and nobody understood it. And I would be sitting in meetings, and they would always say, this code nobody touches because no one understands it. And I felt really bad about it. So I took it on myself, and I spent 2 weeks doing absolutely nothing. I read that code. Every day I go to work, 12 hours I would read the code. At the end of 2 weeks, I came out and said, I got this. I understand how this code works. And I wrote a 4-page describing how this code works. And that was the best of the times and the worst of the times. Because from then on, in meetings they would say, no one understands this code, and their voice would lower with real gratitude and say, except Venkat. It was wonderful to have this badge of honor that I was the only surviving human who understood this code. A good 2 years went by, and they hired somebody way better than me. This guy was Chuck Norris of programming. And he came in and said, oh yeah, no one understands this code other than Venkat, huh? Let me see to it. And he sits down for 2 weeks, spends 16 hours reading the code. At the end of 2 weeks, he comes to the meeting, and in front of everyone, he shames me. He says, Venkat, I have bad news for you. I said, what's it? Well, I have read the code for the past 2 weeks, and I'm here to report to you, your analysis is totally wrong. The code does not do what you said. I bowed my head in shame and said, I'm glad you found this out. Now can you tell me what the code does? He said, I don't know. All I can understand is enough to show you're wrong. I couldn't figure this out. So we got back to no one understood how the code was working. And you can imagine when organizations have code that no one ever can understand how it works. And that's basically a big, big puzzle built into this. Very difficult to handle it. When it comes to imperative style code, we tell how to do and what to do, both mixed into it, and that increases complexity. In declarative style of programming, we focus on what and not on how the code actually works. One of the reasons why functional programming is so exciting is functional programming is declarative in style. So not all declarative code is functional, but all functional code is declarative. So the real expressiveness of functional programming actually comes from declarative style of programming. And the world is moving a lot more with declarative style as time goes on, and we see this happen quite often as we explore and find things. Well, I'm going to talk about clever versus clean code, but it's a really good time to take that break. So we'll continue right after the break. Let's continue. I was saying during the break how impressed I am with the facility and how they've organized. That's really nice to see when people do things right. Definitely want to take the time to express my gratitude to Look for IT and Craftsmen for sponsoring this. I really appreciate that. Bertrand, definitely appreciate you reaching out and giving me this opportunity to be here. So can't thank you enough. So all right, that's a good music too. Okay, so let's talk about when we write code, Programmers have this desire to make the code clever. And we all do. And there's a really good reason for it. And the reason we want to make the code clever is, let's be honest, it feels really good. Because when you make the code clever, you feel proud, you feel enlightened, you feel like, oh, I could show this off, I could tell somebody how clever I was. And you know, it gives us something to talk about. So it's really nice. But unfortunately, what happens when we write clever code is it becomes a liability in the future for us. I remember one experience I could never forget. I got this email from a client saying something has to be worked on, that's an issue that needs to be fixed. And I looked at the problem. I could have fixed this problem in about 10 minutes. But I said to myself, no, I don't want to fix this problem. I want to fix the meta problem. I want to fix the problems of problems. So none of these problems will ever happen again. And I spent an hour doing it. And when I finished it, I had an out-of-body experience. I saw Venkat get off the chair, come and hug me and say, you're awesome. It felt really good doing this. And I checked in the code, and a couple of weeks went by, and I got this email from the client saying something terrible has happened in production. I looked at the problem, immediately responded saying, I got this, I'll fix it. They said, oh, we know you'll fix it because you're good. And I said, no, I can fix it not because I'm good. I can fix it because I'm the one who caused the problem. And what did I do? I rolled back the change I had put in and did the 10 minutes of work, and I checked it in. And I've never had the problem since. Because that meta problem I thought about, it never existed. And sometimes this happens. We want to really take this and solve something in a very clever way. And every single time I do something clever, it comes back to bite me. So what I've learned these days is, when I write something, I look at this and say, that's clever, I immediately delete it, and I start over. So I don't want clever code anymore, I want clear code. And that is something we should really work on. Beautiful quote from Abelson and Sussman, it says, programs written for people to read and only incidentally for machines to execute. We often focus so much on writability of code when we should really be focusing on readability of code. It's not how fast we can write, but how fast we can read the code that really is important to consider. And when it comes to code, there are other problems we have to deal with as well. So here's my theory. 10% of the time we write ugly code for performance reason. The other 90% we write ugly code just to stay consistent with the other 10% of the code. And this becomes really hard to work with. A few weeks ago at work, a fairly young developer walked into the room. We work in a common area. And he walks in the room, and he sits down with a thud, and he just has a big sigh. I said, oh, we're having a rough day at work, aren't we? He said, well, let me ask you this question, he said. I just was in this meeting in this other room, and this programmer has written such a horrible, horrible code. And when I asked him why the code is so horrible, he said, that's the way it should be written for performance reason. So what do you think about it, he said. I said, well, I will answer the question, but before I answer the question, let me ask another question. You said he wrote the code like that for performance reason. Does the code perform? He said, that's the problem, it doesn't. And now you have two problems to deal with. And that is the whole point about this. Those who sacrifice quality to get performance may actually end up getting neither. And this happens quite often because the code is so messed up, when we see that it doesn't perform, it's not even easy to get in and make it better, and that becomes really hard for us to work with. Well, Tony Hoare has a beautiful quote. He says there are two ways of constructing a software design. One way is to make it so simple that there are obviously no deficiencies, and the other is to make it so complicated that there are no obvious deficiencies. And this happens quite often when we don't even know what the code is doing, so we cannot really understand what the problem could be and maybe even fix it. So the next one is a little odd one because this inspiration for this came from a non-technical book. Writing is something we all do to a certain degree, certain extent. But when it comes to writing, well, I could not speak a sentence of English when I was 17. So I started learning and speaking English when I was 18 and 19 years old. And my writing capabilities are pretty horrible. So when I start writing, the people who had to read my writing in the beginning, they are not called editors, they are called victims. And they had to read what I wrote, and one such person took pity in me and said, we're going to help you, and gave me this book. And this book is called On Writing Well. It's a classic guide for writing non-fiction. William Zinsser passed away a few years ago, but he left something wonderful for us. This book was written about 30 years ago. And this book is about writing non-fiction. It's about writing English. And if you're writing an article, if you're writing a book, if you're writing a technical paper, how would you go about writing it? And once I read this book, I was glued to it. I have read this a few times, and I speak about this book a lot among my friends and family. In fact, my son, who is 14 right now, he was 10 years at that time, and he came to me and he said, Dad, and he usually creates a summer reading list for himself. He would typically go for 20 to 40 books he want to read every summer. And so when he was 10, he came to me and said, well, I'm creating my reading list. Could I have this book for reading? I refused to give him my book. I said, it's my book, don't touch it. So I went and bought him his own copy and said, here's yours, because I think this book is not what you want to borrow, you have to own it. And he read the book, and he said something really interesting. He said, this is not a book to be read, it's a book to be reread, he said. And I know he has read this book because he would be reading something, and then suddenly he would say, oh, remember what Zinsser said? And he would just quote out his memory about what Zinsser said. And then he would quote and then say, look at this article, it's written this way. It would be either a critical remark he makes or a one in favor, but he would always quote this. Well, there's a lot of different quotes in William Zinsser's book, but one quote is, he says, hard writing makes easy reading, and easy writing makes hard reading. And in English, he says, if you take more time and effort to write something, people find it easier to read, and the reverse if it is not true. But in this book, he writes about 4 principles for writing good English. As I was reading through these 4 principles, I suddenly realized, wow, the principles he talks about is not for just English, it applies directly to writing code as well. Well, the very first principle he talks about is one we all talk about every day at work. He says, keep things simple. So the first rule he says is, when you write English, you should favor simplicity. When you're writing something, if you make it very complex, you immediately lose the reader. So one of the important things in writing a book or an article or whatever that you write, you always have to start by raising the complexity along the way in a pace with which the reader can keep up. So you want to start with something simple and build on it and keep things simple along the way. This is what we say in code as well. What makes the code complex? Moving parts in code makes it complex. Cohesion, lack of cohesion makes it complex. High coupling makes it complex. A lot of things make code not simple, and we want to really favor simplicity. He talks about clarity. When you write English, you want to make things very clear, he says. Well, same thing in code, we want clarity. What makes writing really not so clear? I have written quite a few things. I've written my dissertation, my thesis, I've written books. I've also read quite a few things. These days I read mostly books which have not been published yet. Publishers would call me and say, would you be a reviewer, read it. So a lot of times I'm reading something that the author has written, but not many people actually have read it yet. Which means, just like I gave the brunt of it to other people, I'm receiving it too. And I see these authors make a mistake that I know very well because I have made the same mistakes before. And that mistake is, when you're writing something, it's in your head, oh, I know this stuff, and you write it down. But then when somebody reads it, they realize, you talk about something here, and suddenly jump and talk about something here, and suddenly jump over here and talk about something, and they are very confused. The flow is lacking. The same exact thing happens not in just English, but in code as well. You're reading somebody's code, and you're not sure what they are trying to accomplish in this code because there is no flow through the logic, and the logic is completely jumbled up. It's really hard to follow that. And that becomes really hard to maintain. Clarity is important, he says. Then he says brevity is very important. He says shorter sentences are better than longer sentences, shorter chapters better than longer chapters, shorter paragraphs better than longer paragraphs, he says. I have to admit to you that I have more open books than closed books, meaning I start reading a book and very few books I actually finish reading. And as I start reading the book, I'll be in the 10th page or the 15th page, and it doesn't matter how technically interesting this topic is, I would lose interest in the book and never go back to read it. And the book will be lying around somewhere where I left it open, and I'm not even interested in closing it because I really want to finish it someday, but gosh, I don't have really patience to read it. But then there are books I read cover to cover, and I read every single word in the book. I couldn't put it down. And a few years ago, I started thinking about it, and I started asking the question, why don't I read that many books and finish them, but why are the books I really read, why do I finish reading them? And then I realized something very interesting. When I was reading one particular book, I realized this very clearly. What I noticed in this particular book was, this particular book, there was not a single page in the book which had a very large paragraph. Most of the pages had 3 paragraphs, if not 4 or 5 paragraphs. And what I noticed was, when I travel, I usually carry a book with me. And during the evenings, when I finish work in a client site or a conference, I would go sit around in a restaurant, I would eat my meal. But when I'm eating my meal, I usually have a book I'm reading. And what I would notice is, in these books, which are things that I couldn't put down, I would read a paragraph. And then when I finish reading a paragraph, before I go to the next paragraph, I would be looking out the window. While my eyes are seeing through the window, my mind is definitely not over there. It is analyzing what I have read. I build stories in my mind, I do analysis in my mind, I think critically about it, and when I'm done with it, I may even take notes about it, and then I come back to start reading the next paragraph. And then I realize something very important. By writing a small paragraph, the author said, I care about you, the reader. And that became very, very clear to me as I started reading books. The ones I enjoyed the most are the books where the paragraphs are shorter and the author really cared about giving you time to think about it before they went on to say more things. In a similar way, when I work with developers, when I review code, I tell them, if you write a function like this, you are not giving an opportunity for the person reading the code to take a breather. But just by inserting one blank line, you are giving a visual cue to the reader. I just finished this little action. I am transitioning to this other action. That one blank line is golden when it comes to writing code. And so we can do a lot of things by encouraging that brevity in code as well. That becomes extremely vital. The last one I saw, I have to be honest, I rejected this. I said, humanity? Oh, come on. We are programmers. We don't need this stuff. So this is where Zinsser's principle doesn't apply to us, I thought. And then I realized how wrong I am. When I work with developers and say, how do you design it, all kinds of crazy ideas come about. When I ask them, how do you design it, or how would we work on this problem, the solutions are much more lively and practical and pragmatic. And I realized that humanity is extremely important when it comes to writing code. And keep in mind that the people writing code, well, we're writing code, but other than the machine, the humans are the ones reading the code more often, and when we have to maintain the code as well, so that becomes extremely important. This reminds me of me going to the optometrist, and she was looking in my eyes and examining it, and said, what do you do for a living? I said, I'm a programmer. And she moved on to talk about other things. A few minutes later, while she was examining my eyes, she said, oh, what do you do for a living? I said, I'm sorry, but I think I told you I'm a programmer. She said, yes, I heard you say it, but I just wanted to confirm because you look almost normal. And sometimes, somehow we kind of give this opinion to people that we are antisocial. Well, I have this theory. Programmers are not antisocial. And I would be on a flight. I'll be sitting in the flight, and you will find me the quietest person on this flight. I will never talk to the person next to me. If it's a 9-hour flight, I want to spend the 9 hours writing code. I don't want to spend the time talking to the person next to me. So I'll just sit down, I'll be just antisocial. But the minute I realize the person next to me is a programmer, we turn into a riot. Because there's so much to talk about, from garbage collection to exception handling, right? And so I have this belief that programmers are not antisocial. We're just social among the right kind of people. So the point really is that humanity is still very important for us, and we have to deal with it, very important. The next one is something really hard for a lot of developers. They believe they have to comment out every single line of code. I'm not saying don't comment at all. But what I'm saying is comment why, not what. And comment why the code exists. What is the reason for us to write this code? rather than what the code is doing. But unfortunately, we've had decades of baggage. Some of us may have been students. And when we were students, what happened? You had the professors who said, you comment the code or you don't get the grades. You said, fine, I'm writing comments. And you write rubbish comment because you know they never read it. And as long as there's a slash and something following it, you are happy with it, they're happy with it. You probably work in companies where they said, if you don't comment, no bonus for you. I'm commenting like crazy. So you get the bonus doing it. So these years of things kind of build up a long way, and it becomes really, really hard. The other day I was looking at a piece of code. It said I++, after that a beautiful increment. I was like, thank you very much, that was very helpful. You see, I'm getting older. As I'm getting older, I can't tell you whether it's plus or something else. This confirmation, this increment is so soothing. But the point really is, I saw this X arrow to shift to with the beautiful shift next to it. Yes, I get it. But first, I don't know what X is. Second, I don't know what 2 is or why it is there. And I don't know why we are shifting either. But these are comments that do not help us at all. But sometimes we come into a situation where people believe they have to really write comments for it. And while I came across a developer recently who got extremely angry with me. And this developer said, I have been writing code for 20 years. I always wrote comments. And you come along and you're doing review of my code and you keep telling me to remove every single comment. I'm totally annoyed with you. And I said, well, because we don't want to comment out stuff that you can read from the code. Make the code self-documenting, self-describing. Comment why the code exists, not what the code is doing. And this person said, but you never give me a chance. I want to write comments and you keep telling me to remove comments. I said, fair enough. Next time you write the code, you write comment. But make the comment worth it. And a couple of days went by. And then I saw this, seriously, I saw this. And the code said, public class, and then it said my class, implements, and then it said comparable, and of course my class, and then below this a beautiful, this class implements comparable. And I'm like, are you kidding me? And this is the problem, is when we are hung up on the fact that we have to write comment, but we don't really realize that these comments are totally redundant and don't add value at all. Well, if somebody tells you, I don't understand this code, comment it. I normally say, I don't understand this code, refactor it. I don't want to comment for a bad code to cover up the bad code. I want to really write the code in a way it is easier to read, easier to understand. So I want self-documenting code. And I'm going to say a good code is like a good joke. You say a good joke, people get it, they laugh. But let's say you say a joke and nobody gets it. The worst thing you ever do after a bad joke is start explaining it. This is really a bad idea. Because when you finish explaining, those very people will look at you and say, oh yeah, and what's funny about that? And now you say, let me re-explain it. It's going to be a very long evening with this person. So what do? You say a joke and nobody gets it. The right response is, never mind. Don't worry about it, never mind. And then you go home and you sit quietly in a corner and you think about how the day went and you refactor your joke. And then you say it with a new group the next day and see how it goes. So a good code is like a good joke. Writing a comment is like explaining a joke. So comment why, not what the code is doing. We want to document the code for its purpose. Why does it exist? What are some of the pre-constraints and what are the post-constraints that we should focus on? What kind of exceptions this could be throwing? Those are valuable form of documentation, but explaining what the code is doing is pretty useless. I came across this one in Washington, D.C. I was there to speak in a conference, and taking a shower is a good idea. So I decided I'm going to take a shower while I was in this hotel before I went to give a talk. And I jumped into the shower, and I'm about to open the water, and I saw this, and I got so angry. And we live in a world where if you're angry, you don't take a shower. You tweet about it. So immediately I jumped out of the shower, went to my camera, and I said, I'm taking a photo of it. And I immediately tweeted this. And my tweet said the following. With this picture, it said, "Those who cannot design are condemned to document." And I got so angry because when I looked at this, I'm like, you idiots, why can't you design in a way that I can actually open the tab and use it? Now you're going to tell me how to use a tab. And that really bothers me because this should be highly intuitive. You don't have to write and tell me, here's how you use the shower. And I feel genuinely insulted when somebody has to teach me how to use a shower. The other day, I was having common cold. I really wanted to take medicine for cold. I was about to toss 2 tablets in my mouth, but I noticed there was something written on this bottle. So I squinted my eyes and read it. And it said, in all genuineness, it said, "Take 2 tablets by mouth." And I'm like, what other ideas do you have for me? I am really not sure anymore. I mean, yes, I'm having cold, but I'm not going to stuff this through my nose. And I think the liars are on it. Similarly, you see this function called int p1, comma, int p2, comma, int p3. And you're like, thank you. 3 integers, p1, p2, p3, but what? Let's write a documentation for it, right? Well, why can't we make this self-documenting and readable? So if I said order 3, I don't know what 3 is, 3 cups. Oh, let's put a comment, large cup of coffee. Or what if we use an enum and say coffee size dot large? Maybe that becomes really descriptive rather than passing some magic numbers around. So commenting is something we have to be very careful about. We want to document code. We want to specify the purpose of the code. We want to tell about various other details about exceptions and pre and post conditions, but we don't want to be explaining what the code is doing. Focus on the why and not the what when it comes to comments and documentation. The next thing I want to talk about here is to avoid long methods. Long methods. Let's talk about long methods for a minute. Who here believes long methods are a good idea? Not a single person raised their hand. Let me ask you a different question. Who here has seen long methods at work? And the hands go up, right? Almost consistently. This is called cognitive dissonance. We know not to write long methods, but how come there are long methods? I'll tell you how. This is a grim realization. There are long methods because the people who believe writing long methods is a good idea are not here today. They are at work right now, making those methods longer as we speak. So there's no hope here. So when you look at long methods, you're looking at the long method and you're trying to understand what this method is doing, and the method keeps on giving. You read it, there's more. Read it, there's more. Read it more. And you're like, more? Keep going. It becomes really hard. What are the problems of long methods? Long methods are hard to maintain, hard to read, hard to understand. They are very hard to test. Somebody said it in a very grim way. I really felt like I should cry when I heard this. He said, very simply, he said, long methods get longer. That is so true, right? You leave a long method, come back the next day, oh, you've grown, right? I think that's a good thing with children, but not with code, because that becomes a disaster over time. Long methods lead to duplication, and they're very hard to reuse. You're looking at a long method and you're saying, oh, long method, I want a part of you. I won't give it to you. Now you got to duplicate it, right? It's hard to reuse, leads to duplication. There are so many reasons why long methods are hard, and yet we write long methods. What can we do about it? Well, we'll come back to that in a minute. I was speaking in Davos, Belgium. I was giving this talk, or no, actually it's a different talk I was giving. And this was a couple of years ago, 2015 in November. And I was talking about long methods in that talk. And the room is a dark room. There are a lot of people in front of me. I can't see them. But I blurted the question, what's the longest method you have seen at work? Wrong question to ask. And out from the darkness came a voice. And the voice said, 40,000. And I'm like, whoa. In one entire class? He said, one method. I said, where do you work, in hell? And I finished my talk, and this gentleman comes over. I could see in his eyes, he was not bluffing. He came to me and said, I'm the one who said 40,000. I said, wow, tell me what's happening. He said, it's worse. I said, how could it be even worse? He said, they interviewed me and hired me to refactor that one method. You should have called for help. You didn't have to take the job. Well, this was in 2015, November. Well, I was there in 2016, November. I was getting ready to give my talk, and he walks over to me. He says, do you remember me? I said, how could I forget you? He said, I don't know why this is happening to me, but I have a brotherly love towards you. And so I feel like I have to come and give you a status update. Would you listen to me? I said, absolutely, brother, go for it. Well, remember we had 40,000 lines. I said, of course, yes, yes. How are things going? Well, I've spent a year refactoring. I've got good news for you. Now we are at 30,000 lines. We both agreed to meet again this November, and we are hoping it'll be at 20,000 lines this time. Well, it's kind of scary when you see this kind of situation. I was mentioning this in Boston, and one of the guys said, I got something better for you. I said, whoa, go for it. He said 65355 or something like that. And I said, whoa, where did you get that number from? He said, that's the limit Java compiler poses on you. There is hope, folks. There is hope. Because you can't go any further than that, right? And actually, we ran into that a few weeks ago at work for other reasons. And I was like, oh, I know what he was talking about. That's the limit. So, well, long methods are evil. So, question is, how long is long? I'm going to say 10,000 is long. Anybody says no? Everybody's okay. 1,000, still long. 100, still long. 50, I heard some people are not sure. The Ruby programmers would say it's long. 10, Ruby programmers would say short. Clojure programmers say long. Well, there's no consistency. That's exactly the problem, right? We cannot take 3 people in our industry and say, agree to what is long, and they can't. Well, somebody gave me a better idea. He said, hey, a method is not long if you can see the entire method in one screen. Yeah. And the minute you say it, the guys say, what's your font size? Well, I'm sorry, we can't win this battle. Well, it turns out the length of a method is really not about the length of the method. It is about the level of abstraction. What does that mean, level of abstraction? Let's try this again. You know this colleague I'm talking about, right, at work, who keeps writing long methods. You have tried a lot. You have told this colleague, don't write long methods. And what does this person do? Write long methods. So I got a suggestion for you. On Monday, go to work, don't say a word. Just sit down and start working. Your colleague, the one who writes long methods, comes to you and says, hey, how was the weekend? I mean, you could tell them how the weekend was. You could say, oh, the weekend was great. On Saturday, I went to the park. On Sunday, I went to the movies. But don't say that. Instead, you say, oh, the weekend. Well, exactly at 7 o'clock on Saturday, got in the car, put it in reverse, took it out of the garage, closed the garage door, took a right turn, drove for about 5 kilometers, took a right turn, drove for 7 kilometers, took a left turn. I missed the exit. Can you believe it? And then I took a right turn again. I had to go 7 more kilometers. Just keep going like this for a while. After a while, your colleague says, excuse me, I asked you how your weekend was. Have you gone mad? You say, no, I've not gone mad, but I thought I'll tell you how my weekend was the way you write code. And the point really is, when you talk to people, you don't talk like that. You give them knowledge chunks. How was your weekend? The weekend was great. On Saturday, I went to the park, and Sunday, I went to the movies. Oh, really? What park did you go to? Oh, the one by the main street. Oh, I've heard about it. Tell me, is the park family friendly? Of course, I took my entire family with the kids over there. That's awesome. What kind of things the kids did? Notice we are drilling deeper and deeper and deeper into this park details, leaving the movie alone. We don't care about it. That's level of abstraction. So when you write code, we want the code to focus on a single level of abstraction. So when we have a piece of code, we want to focus on that level of abstraction. I was doing code review for several months for a team, and oftentimes my comment to them was, break this code into multiple methods, break this code into multiple methods. One day, a developer sent me a code for review, and my review that morning was, merge these methods into one. And he immediately emailed me back and said, okay, I don't get this. You keep saying break it down, break it down, break it down, and when I thought I figured you, now you're saying merge it. I don't get it. What's going on here? I said, oh, I'm so glad you asked, because I kept telling you what to do, but I never told you why I am doing it. And what I'm really after is not the size of the method, The reasons I asked you to break the methods often were it was in multiple levels of abstraction in one. These two methods actually can belong together because they actually are in a single level of abstraction. They don't deserve to be separate methods. This is one of the reasons why when you hear programmers say, I really hate my project because there are too many small methods, that is an example where people were breaking methods into smaller methods without giving consideration to levels of abstraction. So what we really want to go after is the so-called SLAP, which stands for single level of abstraction principle, and focus on levels of abstraction and not the length of the code itself or the function itself. The next thing I want to talk about here is to give meaningful names to variables. Now, this is probably one of the most difficult things for us programmers to do. And you see programmers do this all the time. They give absolutely ridiculous names to variables. I mean, would you do this to your child? Would you name your child P? And child, what's your name? P? Is that your initial? No, that's my full name. Ah, your parents should be programmers then. Well, we don't name children that way. We give them really good names that you can actually say. And yet when we code, we see this variable called P, or K, or Q, or S, or X. I mean, this absolutely looks random. I have a theory. Programmers don't give those names. They are nice programmers. They're coding away, and then they are getting distracted. Maybe there was a phone call they had to attend. And when they put the phone down, they notice their cat was walking on the keyboard. And they're like, oh my goodness, my little cat, kitty, kitty, come here. And they just take it and say, this is wonderful, you named this variable, go play now. And they are sentimentally attached to this variable. My cat gave this name, how precious that is, I'm going to keep it, put a semicolon, move on. Well, but we have to really good names have to be given. I have a definition for a programmer. A programmer, one who can name their children quite easily, but has a hard time naming their variables. I can vouch for it in my own experience. When I was about to have my first child, my wife said, what do you want to call the child? I'm tossing around names. I said, sweetie, I have a really good name for the child. Here's the name. She's like, wow. I mean, not that I don't like the name, it's a really good name. Maybe you want to spend some time thinking. No, I don't have to think about it. This is the name I would like to give. It's okay with you. Do you want to maybe toss it around? Sweetie, that's the name I want to give. You can toss it around, but if you give me some space, I got to think of variable names now. Well, it's a really, really hard problem to solve, right? We cannot just throw variables around. Finding name for children is a lot easier, at least in my personal experience. I was working on a project. This project, a single license is $1 million. Just one license, $1 million. And I was helping them to make some improvements to project, doing reviews. And one of the developers opened a file, and he jumped over to another file. So go back to that file that I just saw. And he did. And he showed me the code. I said, I won't tell you anything about the company name. I won't do anything. Can you just allow me to take a photo of that one line, that one piece of code? He said, yeah, go ahead and take it. So I took the photo, and here it is. Well, actually, what I wanted to take photo was not this line, the line right below this. It said, God help me, I have no clue, no idea what this means. These are the developers in charge of maintaining this code. I always get this impression when I see comments like this. You see this comment and you look down, there's dry bone on the floor. Last call from this programmer before they died, right? I couldn't figure this out. When people come to me and say, what do you do for a living? I don't say I'm a software programmer anymore. I say I'm a software archaeologist. Because I go to work and say, what does this do today? Right? I'm sure it did something. We all have these opinions about code. I think this is what the programmer meant. No, I think this is what they meant. Well, it was a winter time when they wrote it, right? We're trying to analyze these things and figure out what the code is doing. So the point really is the variable names represent abstractions. They're very important. And if we don't really know how to name variables, maybe we haven't really understood its purpose. The next thing I want to say is do tactical code reviews. I know what some people are thinking. You're saying, are you crazy to talk about code reviews? Well, I think a lot of people are doing code reviews really in the wrong way. You bring people into a room, you project the code on the screen, and then we talk about it. That is not called code review. That's called let's insult each other. And it becomes a political battle at that point. And then the boss comes to you and says, wait, run this by me again. You want to do code review next week? Is it kind of like the ones you did 2 Thursdays ago at 2 o'clock in the afternoon? Oh yeah. Heck no. Because the last time you did this, there was a fight. We had to call the cops and 2 people quit. No more code review for you, right? So people don't want to allow code reviews because it becomes a battle. Well, there are a few things I want to say first of all. And I'm not saying I'm perfect. I'm as flawed as a human being as anybody else is. But I'm trying really more and more to do this. Keep in mind, first of all, you never review code. You always review the person who wrote the code. It is personal. We cannot separate the person from the code they wrote. So when we tell somebody about code that they wrote, it is 100% important to be constructive and positive. So one of the rules I like to follow is never tell what is wrong in the code. Always tell what can be done better. I look at a long method. My comment should not be, gosh, this is a long method. What were you, drunk when you wrote this? Versus, hey, I'm looking at this method. I'm wondering if we should break this into 2 methods maybe. And here are the method names I'm thinking about. What do you think? So we are giving a path of exit for them to do something better, elevating them to do some work. Always make a suggestion as to what they can improve. One of the other things we also do is we do what are called tactical code reviews. And I can't tell you how effective this is. I'm absolutely committed to this. So when I write a piece of task, I'm going to ask him to review the code. The next piece of task I write, he is going to review the code. A third piece of task I write, a third person is going to review the code. We're going to rotate among the people to review the code. In the meantime, the code he is writing, I'm going to review this time, next time he's going to review, and so on. We'll move around for people. So the whole point about this is we have one person reviewing the code. We're not bringing the team together to do it. And secondly, when we have these kinds of code reviews, I not only review the code, I review the test as well. In fact, I don't review the code. I review the test first, and then I review the code. And some teams I work in, they write really good code. I don't have much to say about the code, but I often say, hey, you should really think about these 2 tests that you're not writing at this point. One of the things I started doing about 7 years ago really changed the way I do code reviews. Until that point in time, 7 years ago, when I'm reviewing somebody's code, I would find a bug. When I found a bug, I would write a paragraph. I would write a paragraph that says, did you realize that if you send this value between the range of 200 to 300, the code will not really do the job and it'll give you wrong results, you need to fix it. Instead, that day I had a little epiphany and I said, oh, wait, let's think about this a little differently. And I said, what if I write a test that fails because of this bug? Now clearly writing that paragraph is faster. It took me about 10 minutes to write this test. But when I wrote the test failed. I quietly checked in the test, didn't say a word. The continuous integration build actually broke, and I'm happy with that, perfectly fine with me. When the build broke, the developer who wrote the code originally and me got a notification that the build broke. Hey, I'm the one who broke it for an intentional reason. I'm not going to do anything. Well, the other developer looked at it and said, looks like my code is broken. And who touched it? Oh, Venkat touched it. Let me see what's happening. And he goes in there. And he finds that I've actually written a test. And he's like, I see what's going on here. An hour goes by, and he comes to me and says, I see what you did over there. You wrote a test because you found a bug. And then he goes on to say, but did you know there were 3 more bugs in there? And then he proudly says, so I wrote 3 more tests and checked them in and fixed the bugs. And I said, my job here is done. Because that's the whole point of this. You don't want to fix a bug without writing a test for it. And when that becomes a habit by doing it, it sticks on. And I've done this for about 7 years now, except there was a little variation to it about 6 months ago. I saw a bug, and so I said to write a test for it. And I spent 30 minutes on it. And I could not write a test that fails because of this perceived bug I had in my mind. And that's when I realized there was not a bug at all. It's just that the code was so messed up, I didn't really understand it properly. So now my recommendation was how to refactor the code to make it very clear rather than saying that you got to fix a bug. So that can be very useful as well when it comes to dealing with this. So I'm a huge fan of these tactical code reviews. And the last thing I want to talk about here is, if you ask me, what is one thing you're doing different today than you've been doing for a long time? And I'll tell you one thing I'm doing very different today compared to what I did 10 years ago. 10 years ago, I created code that was object-oriented and bloated with state. And I see a lot of programmers do this today. They would start public class, name of the class, curly bracket, what's the next thing they do? Private and put a field name. When I work with teams and coach them, I always tell them, don't create a class with field in it. I don't want state to be self-serving. I want a state to be there to work and serve a behavior, not a state itself. So these days when I work with developers and for myself, I create a class, I create methods in the class. And only when a method forces a variable to exist, then I decide if that variable should exist in the class. And so I reluctantly bring in state into classes, not too eagerly. But reducing the state has been really helpful. So think more typeless, aim for minimalism, fewer states, less mutability, and just enough code for known relevant parts of the problem. A little bit more philosophically, I will say, messing with state is the root of many problems, both in software and in politics. And this happens a lot. Why do governments keep fighting with each other? Because they can never keep their hands out of somebody else's state. So we want to really minimize state. That's very important. But it turns out that mutability needs company. It often hangs around with bugs. And I repeatedly see errors in code, and we remove mutability, the bug kind of goes away with it as well. So we can really help that quite a bit by reducing state in our code. So we talked about 12 ways to make the code smell less. So we talked about scheduling time to lower technical debt, favoring high cohesion, favoring loose coupling, program with intention, and then we talked about avoiding primitive obsession, clear instead of clever code, the Zinsser's principle on writing, comment why, not comment what, avoid long methods, apply the SLAC principle or single level of abstraction principle, give good meaningful names for variables, do tactical code reviews, and finally reduce state and state mutation. But I want to leave one departing thought before we call this done. We all have pressure to write code. Oftentimes people ask us, are you done with the code? You should have finished this yesterday. It's really insane because in organizations we work, both technical people and non-technical people come to us and say, you should write this code really quickly. Are you done yet? I was in Madrid walking through the museums, and I saw a room with Picasso's painting. On one wall, they had maybe about 17 different paintings of Picasso. All of these paintings on this particular wall, on the very right side was his masterpiece that everybody knows and talks about. But left of the masterpiece, the other paintings on that wall were not his other paintings. Those instead were prototypes he had created before he arrived at that masterpiece. Far left was the initial thing he created, which looked very different than what he has intended to create. And you can see that evolved over and over and over, and the different ideas he has thrown together. So we see even the greatest of artists in our in the world have created many, many different prototypes before they created the code the end product they wanted to create. Then we come along to write code, and we tell ourselves, you got one shot at it, which really is silly in my opinion. So the concluding thoughts here, or departing thoughts here is, the first step in becoming a better programmer is to let go of the conviction that we can code it once and get it right on the first write. So I think the code is never written. The code is always rewritten. And the quicker we can get to start rewriting it and refactoring it, I think we have a better chance at it. Hope that was useful. Thank you.